Thank you. I'm co-chairing the architecture group with Dan Daly, who's at Intel, and a little bit of motivation. You all heard already that P414 has been targeting PISA, and which is a single pipeline really defined the need for programmability. So it brought awareness that, hey, we can do these pipelines in a programmable fashion. But as we started using it and building a variety of devices around programmability, we realized that, well, we've outgrown this single pipeline. So what we want to look is how can we build and how can we allow you as P4 developers and P4 vendors build more interesting P4 devices and programs. And really, the architectures, what they do with the language is separation of concerns, right? You want to program your data plane, and you don't want to worry too much about how it gets executed and mapped to the target. You want to give the compiler the ability to do that. So what is an architecture? Well, if you come from the general purpose programming world, you think about programming models. That's your mental model, your programmer's view of the target. And you can make it look nice and clean and straight and everything. And it's really separating the hardware target from the mental model that you want to build your program. And then you can take that program and move it to multiple targets. So architectures in P416 really enable this diversity of devices. We have now, hardware, switches, routers, NICs, FPGAs, you name it, each of them, different kind of abstractions underneath. Well, of course, all of them are related to data planes, so tables and match action are still very present there, but you can see how you can add controls and you can add externs to build other functionality. And of course, you can use software switches as well, right? So, like I said, in general, you provide a logical view of the processing with this really nice view that insulates you from the messy kind of hardware pipes that you have underneath there. And you rely on the compiler to really build you that mapping between your nice logical view and all the hardware details in the target. So what are we doing in the working group? Well, the goal is to develop this, what we call the portable switch architecture, which is an architecture that can be implemented ideally on any target. Of course, there are limitations, so we will have to think carefully about what do we put in this architecture. But really the goals of having this portable architecture is for people to have something that they can start thinking about how do I build an application, a program, a P4 program with multiple components that can possibly run distributed, but they have the same mental model across all this variety of devices. And we think it's actually very, very important, and this is one of the things that with P416 we will continue to emphasize, this modularity and composability of P4 applications. We started the community. It's been all very nice and gung-ho, and all of you are writing programs in P4. Well, it will come a time when we want actually to be able to pull in multiple programs and reuse code, and this is where composability and modularity comes in. This is where targeting a certain standard architecture or portable architecture will give us the ability to actually start reusing that code. And we really think this is one of the more important things that we can do with P4 to really make it grow beyond writing papers in academia. One of the non-goals of this architecture work is actually performance portability. So we allow you to run the program across multiple devices. We are not going to guarantee that it will get the maximum performance on any device that you can imagine. Yes, we will make every effort to have the compiler do the best job it can to map it to the target, but I've been around compilers for most of my career, and one of the things that I keep saying is the compiler is not the magic wand, right? It's not going to make your nice, clean program and do all the optimizations and all the possible mappings to the complex architectures that we are building. So this is something that you need to keep in mind. We are targeting portability. We want to be able to run on multiple devices, but we don't necessarily guarantee the maximum performance on every device. So what is PSA? What is the portable switch architecture? We call it PSA. Well, it has the pipeline that you've seen in PISA with the addition of a bunch of externs. And these are the current externs that we are discussing that we would like to see whether they can be implemented on a variety of devices. And well, that's what the working group is doing. So we have a draft available. We have a GitHub repository for the PSA together with the P4C compiler. And we will have a mailing list. It's getting set up. So please join the GitHub discussions for now, and then the mailing list will announce it to the P4 announce mailing group when we have it available.